Today we're going to cover normal and shear stress. We're going to look at a past exam problem. So the yoke and rod connection is subjected to a tensile force of 15 kilonewtons. So tensile is whenever the force is pulling outward, so it's going to end up like stretching the object because it's pulling it outward. If it was pushing it inward, then that's a compressive force. So the question asks us to determine the average normal stress in each rod and the average shear stress in pin A between the members. We also have what happens to the shear stress in pin A if one side of the yoke is broken. So we'll talk about that in a little bit. So first, they ask us for the normal stress in the two in the two rods. So I started off with this rod. I pretend like I'm cutting the rod in half and I take this chunk to the left. So I have my 15 kilonewtons, then I draw a normal force, and I know that the normal force is going to be equal to 15 kilonewtons because this is the only force we have here. So now the normal stress of this chunk is just the normal force divided by the area. So I take 15 kilonewtons divided by pi r squared, and I end up with 7.639 megapascals. So that's pretty straightforward. Then I move on to the other rod to the right. Once again, I pretend like I'm cutting the rod, and I look at everything to the right of the cut. So I have my 15 kilonewtons, and then I normal force, which is just 15 kilonewtons. And I do the exact same thing here. I do the normal force, so 15 kilonewtons divided by the area, pi r squared. So the only difference here is the fact that this has a diameter of 50 millimeters and this has a diameter of 30 millimeters. So I end up with 21.22 megapascals. Alright. Now that I've determined my two normal stresses, they ask for the shear stress in the yoke at pin A. So if we look at the pin, so this is our pin, and we have the 15 kilonewton force pulling this way. We end up with two shear members, or two shear forces, one on each side of the pin. So that basically means that 2V equals 15 kilonewtons, so our shear force is just 7.5, right? So one of these is equal to half of 15. So the overall shear stress is the shear force divided by the area. So 7.5 kilonewtons divided by pi r squared, and it's the area of the pin, so we use the 20 millimeters, and we end up with 23.87 megapascals, and that is our shear stress. Now the second part of the question asks us what happens if one side of the yoke breaks and we only have a shear on one side of the pin. So this basically means that instead of having two V's, we have one V. So our shear force just equals 15 kilonewtons. So instead of having double shear like we had here, we have two shear forces. We end up with single shear. So we do 15 kilonewtons divided by the area, and we end up with 47.75 megapascals. So the only difference here is that our shear force ends up being larger because our shear stress ends up being larger, twice as large, because we only have one shear force instead of having two at the pin. It's a pretty straightforward question, and